Looking at similarity second handout. So let us look at the first question together. Here we have, this is a parallelogram. During this one, we're going to be looking at only the definition of the quadrilateral, and then that as a given, and we will not assume anything else here. So PQRS is a parallelogram with diagonal QS. That means we know that this one is parallel to this line. All right. Now QS and then TW intersect at Z. And we want to prove that TSZ, which means we're looking at TSZ, this yellow triangle, and then its corresponding part. Now, how are we going to do that? First, I guess we can see the vertical angles. But the second one is, because these two line segments are parallel, we can say that this one is an alternate interior angle to this angle. And therefore, we have two pairs of congruent angles, AA, possibly. All right, so let us write this one up together. Statement and then reasoning. So first, I'm going to assume that all these things are written over here, and then the reasoning it will be given. Now, second, as soon as we realize that the line segment PS is parallel to QR, in parallelogram, opposite sides are parallel. All right, let us look at number 3. Therefore, here we realize angle STZ is congruent to angle QWZ. Why? In parallel lines, alternate interior angles are congruent. So that's why we have congruent angles right over here. And step number 4, we can say angle QZW is congruent to angle SZT. Now, of course, these are vertical angles. Vertical angles are congruent. All right. Now, since we made up the two pairs to be congruent, step number 5, then we can say finally, triangle PSC is similar to triangle QWZ. Now, reasoning would be AA postulate. All right, that's it. Let us move on to the second question. Here, sides of the triangles measures 3, 5, and 7. Okay, smallest side of the similar triangle measures 9. Then you will realize that this smallest one from the first triangle is corresponding to 9. Just want to give you a little bit of drawing. For example, I'm looking at this one, and then let us say the other one is something like this. And then one side here is 3, and the other side is 5, and let us say this is 7. And then its corresponding size, since 9 is the smallest, and 3 is smallest from the smaller triangle, then you will realize that 3 becomes 9 by multiplying by 3. Then 5 becomes 15, and then 7 becomes 21 by all multiplying by 3. And 5 is the longest side. Yes, it is 21. Alright, let us look at number 3. Which polygons are always similar? Now, in order for polygons to be similar, there's two conditions that has to be met. Our first condition is not only the angles, but also the ratio of the sides. But in this case, actually, we realize the equilateral triangles, because equilateral triangles have always congruent angles all throughout. Therefore, all equilateral triangles will be similar. Right, now let's look at number 4. Okay, here comes another proof. In the parallelogram, that means PQRS. PQRS. So we get to realize that this side is parallel to this side once again. And let us continue. Not only that, this side is parallel to this side too. We'll see which one we'll be using. Now, and we are the fact that we are looking for PT. PT means we are looking at this side. PT right over there has to be corresponding to PW. And obviously we're looking at the upper triangle, and that ratio has to match with QR, which is this one, and then QW. So by highlighting, it seems to be quite clear that we need to compare this triangle to this triangle. Let us see what we can do with it. Obviously, first we have the one vertical angle. The second one will be, because this line is parallel to this line, we get to realize that this angle must be congruent to this angle by alternate interior angles. And then obviously we have to go for corresponding size being in proportion. So let us try to look into this one together. So we have statement and then reasoning. First, we're going to assume that these are all over here as a given. Now, step number 2, because they are parallel, we get to realize parallelogram. We get to realize that SPT is parallel to QR. Because I'm going to say definition of parallelogram. Because definition of the parallelogram will be opposite sides are parallel. Number 3. And therefore we get to realize angle T is congruent to angle QRW. Because in parallel lines, alternate interior angles are congruent. Now, once again, we see the vertical angles here. So angle PWT is congruent to angle QWR. Because vertical angles are congruent. Now, step number 5. Then I think we can say that these two, green triangle and then yellow triangles, are congruent. I mean, similar. Triangle TPW is similar to triangle RQW. Number 5 will be AA. Now, number 6. Then we can say PT over PW. That ratio is equal to QR and QW, because in similar triangles, corresponding size sides are in proportion. All right, that's it. Let us move on to the next question. Number 5. Two isosceles triangles have congruent vertex angles. That means we realize that in two isosceles triangles, let us say this one, and we have something else. Let us say the other one is, so we have no idea about their size. So one thing that we get to realize, if this angle is congruent to this angle will be left over from here, taking away that angle from 180. These two angles must be congruent, so is these two. Then we realize that all the angles are congruent between triangles. That means those two triangles must be similar. All right, number 6. Here we have AB is parallel to CD. Then, once again, we get to realize the vertical angles and alternate interior angles. That's it. So once again, statement and reasoning. Number 1, AB and then CD, those are the givens. Number 2, then angle A is congruent to angle D. The reasoning behind this one will be, of course, in parallel lines, alternate interior angles are congruent. All right, step number 3. Always the vertical angles here. So angle CED must be congruent to angle BEA. Now, because vertical angles are congruent. All right, number 4. After we have set up two pairs, then we can say those two triangles are congruent. I mean similar. So we have triangle CDE is similar to triangle EAE. Now, step number 4 is going to be AA. And step number 5, we can put the proof statement right over there. And number 5 will be corresponding size in similar triangles are in proportion. All right, that's it. Let us move on to number 6. So here, all these line segments are given, and we're looking for CE. Let's call this one as X, because we know that all sides are in proportion. So 6 to the big size will be equal to 6 plus 3, which is 9. The ratio is 6 over 9. That should be equal to 10 smaller triangle over the entire thing, which is 10 plus X. Now, how are we going to find out the value of X? All we have to do is simply cross multiply. Then we get 90, which is equal to 60 plus 6X. Then by subtracting 60, we get 30 equals 6X, where X is equal to now what? 3. X equals 5. Yeah, so choice B. Now, number 8. The ratio of the corresponding size, 7 and 5. Find the ratio of their perimeters. Okay, so why don't we assume that we are looking at two triangles. This is one triangle, another one is similar to that, but a little bit bigger. So here we have each side is 5x, 5a, 5b, and 5c. But on the other hand, we have 7a, 7b, and 7c. What are their perimeters? Perimeters here becomes 5a plus 5b plus 5c. Now, which is equal to simply 5 times a plus b plus c. Alright, but on the other hand, this one, perimeter becomes, by factoring out 7, we'll end up getting 7 and a plus b plus c. Once again, we have the ratio between these two triangles in terms of its perimeter is 5 to 7, or 7 to 5, depends on how you look at it. Alright, number 9. Altitude drawn to the hypotenuse of a right triangle forms two triangles similar to each other. Now, similar to each other, then in this case, so I'm going to draw a right triangle here. And then let us assume that an altitude is drawn here. So, we have right angle, we have right angle. Then, how can we show that these two triangles are similar? We have to show that two pairs of the sides, or two pairs of the angles have to be congruent. So what if I were to mention that this is dotted angle? This is double dot. Then when you look at the triangle on the left side, one dot plus two dot becomes a complementary 90-degree angle. You see, because one angle is already 90 in this left-sided triangle. How about, since this is two dots, what will be the measure of this angle? There will be one dot to make that into 90 degrees. Since this is one dot, then what do you think this angle would have been? Two dots. So in fact, you will realize that three pairs of the angles are congruent. So let us try to write this one up. Then we'll simply say, for this question, we're not going to write it out, but simply we're going to say each one of them has one right angle and one marked angle. Therefore, by AA, we can show that these left and right triangle will be congruent, similar to each other. All right.